has confirmed it's launched an attack on Iran.
At exactly 1400 local time in the Persian Gulf, the calm surface of the water hides a moment that will soon force military planners in Washington, Tehran, and every major energy capital in the world to pay attention. A massive oil tanker worth billions of dollars is slowly crossing one of the most strategically important waterways on Earth. It carries enough fuel to influence global markets. And for the crew on board, it seems like just another routine transit through dangerous waters. But somewhere beyond the horizon, a plan has already been set in motion. On the Iranian coast, operators monitor screens filled with radar sweeps and telemetry streams. Dozens of small aircraft sit ready on improvised launch rails. They are not traditional weapons of war. They are cheap, disposable drones designed for a single purpose: overwhelm defenses through sheer numbers. Within seconds, engines ignite, and the first wave rises into the air. One drone becomes 10, 10 become 30. In the quiet control rooms, operators watch their swarm assemble like a cloud forming over the Gulf. Far away at sea, American sensors begin to notice something unusual. The first signals appear as faint blips on long-range radar. At first, they seem insignificant, too small, too scattered to resemble a conventional strike. But the pattern changes quickly. The contacts multiply, their speed increases, their formation tightens. Within moments, the situation becomes clear. A coordinated swarm is moving directly toward the tanker. What makes this situation dangerous is not just the number of drones. It is the strategy behind them. Each drone costs almost nothing compared to the sophisticated missiles designed to destroy it. In modern warfare, cost matters. Every interception decision becomes a calculation. Spend millions of dollars in missiles to destroy machines worth a fraction of that? Or risk letting them get closer? This is the dilemma commanders now face. On board a nearby American destroyer, the Combat Information Center lights up as systems switch from monitoring mode to combat readiness. Radar operators track the swarm as it spreads across the sky like a widening net. Every second brings the drones closer to the tanker. At the same time, helicopter crews scramble on the flight deck. Pilots strap in, engines roar to life, and rotors begin to cut through the humid Gulf air. Their mission is simple in theory, but incredibly difficult in practice. Intercept the swarm before it reaches its target. Meanwhile, somewhere above the horizon, fighter aircraft patrol silently, their sensors scanning for any additional threats that might follow the drones. In modern conflicts, swarms are rarely the whole story. Sometimes they are only the first move. For the crew aboard the tanker, the attack is still invisible. They hear only the sound of the sea and the low hum of engines. But in the combat centers surrounding them, every screen shows the same reality. A countdown measured not in minutes, but in seconds. What happens next will demonstrate something critical about modern warfare: how technology, strategy, and timing collide in a battle where even the smallest machine can threaten one of the world's most valuable targets. And when the first interceptor launches, the sky over the Persian Gulf will turn into a battlefield of speed, precision, and ruthless mathematics. At 1400 local time in the Persian Gulf, what should have been an uneventful transit through one of the world's most heavily trafficked energy corridors suddenly begins to unfold into something far more dangerous. The tanker Atlantic Horizon, a massive crude carrier valued at more than $2 billion including its cargo, moves slowly through the narrow maritime lanes leading toward the Strait of Hormuz. On board are over 2 million barrels of crude oil destined for refineries in Asia. Ships like this pass through the region every day, but everyone in the industry knows that this stretch of water is also one of the most politically volatile places on the planet. The Persian Gulf carries nearly a fifth of the world's traded oil supply, and any disruption here can ripple instantly through global markets. Insurance companies track every movement, naval forces patrol the routes, and satellite systems constantly monitor the traffic below. On the bridge of the tanker, the crew follows standard security procedures. Radar screens sweep the surrounding waters while watch officers keep an eye on nearby vessels. The ship's captain has already received routine warnings earlier that morning about increased military activity in the region, something that has become common during periods of tension between Iran and the United States. But roughly 160 kilometers away along the Iranian coastline, activity is far from routine. At a small coastal installation believed to be operated by a unit of Iran's Islamic Revolutionary Guard Corps Navy, technicians begin preparing a launch sequence. Several compact drone launch rails have been set up along a rocky shoreline facing the Gulf. The drones themselves resemble variations of the Shahed loitering munitions that have appeared in multiple conflicts over the past few years. In reality, these systems are relatively inexpensive, often costing tens of thousands of dollars rather than millions like advanced cruise missiles. But their true strength lies not in sophistication, but in numbers. Shortly after 1402, engines ignite one by one. The first drone lifts into the hazy Gulf air, followed seconds later by another and another. Within 3 minutes, more than 30 small aircraft are climbing and forming into loose attack patterns. Some carry simple high-explosive warheads. Others appear equipped with guidance systems designed to adjust their course during the final approach. Analysts later suggest that several of the drones may also have been fitted with experimental signal relays, allowing operators to coordinate the swarm from far greater distances than previously believed possible. What makes the moment especially tense is the timing. The attack window appears carefully chosen to coincide with a period when commercial traffic is dense and visibility slightly reduced by humidity drifting off the water. From a distance, the swarm initially looks like scattered radar noise, rather than a coordinated formation. For several minutes, the drones fly low over the water, using terrain and wave clutter to reduce the chance of early detection. On board the Atlantic horizon, nothing seems unusual yet. The ship maintains a steady course at just under 15 knots, escorted at a distance by a coalition naval patrol that has been monitoring tanker traffic throughout the region. The crew continues routine operations, unaware that dozens of small aircraft are now racing across open water toward them. At approximately 1411, the situation begins to change. One of the long-range radar systems aboard a nearby U.S. Navy surveillance aircraft detects multiple low-altitude contacts emerging from the Iranian side of the Gulf. At first, the signals appear inconsistent, flickering between returns that resemble birds, debris, or small drones. But as the radar sweep refreshes, the contacts multiply. Within seconds, analysts realize that the objects are moving in a coordinated direction. Their trajectory leads directly toward the tanker's position. What began as a quiet afternoon transit through a strategic waterway is now evolving into a potential attack scenario. The distance between the swarm and its target is still significant, but in modern aerial engagements, that distance can disappear faster than anyone expects. Naval command centers across the region begin tracking the situation, and a silent countdown starts in the skies above the Persian Gulf. As the first wave of drones climbs into the humid air above the Iranian coastline, the attack begins to take shape with deliberate precision. What initially appeared to be scattered launches quickly transforms into a coordinated swarm moving steadily across the Persian Gulf. The drones spread into multiple loose formations, maintaining enough distance from one another to avoid a single interception, wiping out several targets at once, yet staying close enough to preserve the swarm's overall structure. From above, their flight paths resemble a slowly tightening funnel aimed directly at the tanker's projected route. Most of the aircraft resemble variants of the Shahed 136 loitering munition, a design that has drawn attention in several recent conflicts. These drones are relatively simple compared to advanced cruise missiles. They are powered by small piston engines that produce a distinctive buzzing sound, sometimes compared to a chainsaw or motorcycle engine. Their wings are triangular, giving them a recognizable silhouette in infrared and radar signatures. Despite their simplicity, they can travel hundreds of kilometers using satellite navigation, combined with pre-programmed routes. Their relatively low cost, often estimated in the tens of thousands of dollars, allows them to be deployed in large numbers without the financial burden associated with more advanced weapons. But the real strength of the attack lies in its layered structure. The drones do not travel in a single straight line. Instead, operators appear to have divided them into several groups, each approaching the target zone from slightly different angles. Some fly extremely low over the water, using wave reflections to confuse radar systems. Others climb to higher altitudes where their guidance systems can maintain stronger satellite signals. Military analysts later described this pattern as a distributed pressure tactic, designed to force defending forces to divide their attention across multiple directions at once. Adding to the complexity, small fast boats are reported leaving a coastal harbor roughly 10 minutes after the drone's launch. These boats resemble the high-speed craft commonly used by Iran's Revolutionary Guard naval units. In past exercises, similar boats have been used to simulate swarm attacks against larger ships, relying on speed and maneuverability rather than heavy firepower. Although their exact role in this scenario remains unclear, intelligence reports later suggest they may have been intended either as decoys or as secondary strike elements if the drones manage to disrupt the tanker's escorts. As the swarm continues across open water, the distance between the drones and the tanker begins shrinking rapidly. Traveling at speeds estimated between 150 and 180 kilometers per hour, the drones cover vast stretches of the Gulf in minutes. At this pace, the initial detection window for defending forces can be surprisingly short, especially if the drones remain close to the surface. One particularly unusual element of the attack becomes apparent through signals intelligence collected later. Several drones appear to broadcast short bursts of encrypted communication between each other during the flight. While the Shahed family of drones is typically known for following preset GPS routes, some analysts speculate that these transmissions could represent experimental attempts at limited swarm coordination, allowing drones to adjust spacing or react to changes in the target's movement. Whether these signals actually influence their flight path or simply relay telemetry remains uncertain. Meanwhile, the swarm itself continues organizing as it moves deeper into the Gulf. The drones form staggered waves, with the first group acting almost like scouts, while the following groups maintain a slightly higher altitude and wider spacing. This configuration could serve several purposes. If defensive missiles are launched at the first wave, later drones may still slip through gaps in the defense. Alternatively, the early drones might trigger radar systems and reveal the positions of naval defenses protecting the tanker. By the time the swarm reaches the midpoint of the Gulf, the attack has clearly transitioned from a theoretical threat to an active operation. What began with a few small launches along the Iranian coast is now a moving formation of dozens of unmanned aircraft heading toward one of the most valuable targets currently at sea. With every passing minute, the distance continues to close, and the complex geometry of the attack forces, defending forces to prepare for a confrontation that is now rapidly approaching. Several minutes after the swarm has already crossed deep into the Gulf, the first clear confirmation of the threat appears inside the radar displays of an American E-2D Hawkeye surveillance aircraft orbiting high above the region. The aircraft, part of the U.S. Navy's Airborne Early Warning Network, carries one of the most advanced rotating radar systems currently deployed at sea. From its altitude of more than 25,000 feet, the Hawkeye's sensors can scan vast sections of ocean and airspace simultaneously. At first, the operators notice a cluster of small returns emerging from the northern sector of the Gulf. Individually, the contacts appear insignificant, barely distinguishable from interference caused by waves or atmospheric conditions. But when the radar completes another sweep 12 seconds later, the pattern becomes impossible to ignore. The contacts have multiplied and are moving with clear directional consistency. Within moments, the operators classify the objects as a coordinated group of unmanned aerial vehicles. Their flight path leads toward the commercial shipping corridor where the tanker continues its transit. Data links immediately transmit the coordinates to nearby coalition naval forces. In particular, the information flows directly into the combat systems aboard the Arleigh Burke-class destroyer USS McFall, which has been operating as part of a maritime security patrol in the region. Inside the ship's Combat Information Center, large displays illuminate with fresh tracking data as the Aegis combat system begins building a predictive model of the incoming swarm. The Aegis system is designed to process enormous volumes of sensor information, combining radar inputs from the ship itself with data from aircraft and other vessels. As the Hawkeye continues updating the drone tracks, the destroyer's Spy-1 radar begins confirming the targets independently. Each small contact appears on the tactical display as a moving symbol, and soon the screen fills with dozens of them. Operators calculate projected intercept paths, estimated arrival times, and the possible threat each drone represents if it reaches the tanker or nearby naval ships. At this point, commanders face a familiar problem in modern warfare. Traditional ship-launched air defense missiles, such as the RIM-162 evolved Sea Sparrow, are extremely capable, but also extremely expensive. Each interceptor can cost well over $1 million. Using them against inexpensive drones may technically solve the immediate threat, but it creates a dangerous imbalance in the economics of warfare. A large swarm could potentially drain valuable missile inventories within minutes. As the drones continue approaching, the tactical calculations grow more complicated. Launching long-range interceptors too early could waste precious weapons on targets that might later be destroyed by other means. Waiting too long risks allowing the swarm to close the distance where reaction time becomes dangerously short. The Combat Information Center fills with quiet tension as officers analyze possible engagement options. Every decision must balance cost, timing, and the probability of success. Meanwhile, flight decks on nearby ships are already moving into action. Two MH-60R Seahawk helicopters lift into the air, their rotors beating against the humid Gulf atmosphere as they accelerate toward the approaching threat. These aircraft are commonly used for anti-submarine and maritime patrol missions, but they also carry weapons suited for engaging smaller aerial targets. Among those weapons are Hydra 70 rockets equipped with the APKWS laser guidance kit, a system that effectively transforms a simple unguided rocket into a precision strike weapon at a fraction of the cost of traditional missiles. As the helicopters close the distance, their onboard sensors begin scanning the sky ahead. The drones themselves are still difficult to see visually, appearing only as faint specks against the bright horizon. But infrared targeting systems soon begin detecting the heat signatures from their small engines. One by one, the drones appear on the helicopter crew's targeting displays. Their formation is now clearer, staggered lines moving steadily toward the shipping corridor. The pilots coordinate their approach carefully. Unlike high-speed fighter engagements, this interception requires precision and patience. The helicopters position themselves slightly ahead of the swarm's projected path, allowing them to engage targets as the drones pass through their firing envelope. Laser designators activate, projecting invisible beams that guide the rockets toward selected targets. The first rocket leaves its launcher with a sharp burst of smoke and flame. Within seconds, it arcs across the sky and strikes one of the leading drones. The explosion is small but effective, shredding the lightweight airframe and scattering fragments into the water below. Immediately, another rocket launches, followed by several more in rapid succession. Each guided projectile costs only a fraction of what a traditional interceptor would require, allowing the helicopters to engage multiple targets without exhausting expensive missile inventories. As the drones continue closing in, the pace of the engagement accelerates. Rockets streak through the sky, leaving thin white trails that briefly linger in the humid air. Several drones attempt to alter their course during the final approach, but the guidance systems of the APKWS rockets adjust rapidly, correcting their trajectory moments before impact. One after another, the small aircraft detonate in midair or plunge into the sea, trailing smoke. Still, the swarm's size means that not every drone can be intercepted immediately. A number of them slip past the helicopters and continue toward the tanker's position. That is when the destroyer itself enters the fight. On the deck of the USS McFall, the Phalanx close-in weapon system activates automatically. Often referred to simply as CIWS, the system is designed as the last line of defense against incoming threats. Its radar locks onto targets approaching the ship and directs a 6-barrel Gatling gun capable of firing thousands of rounds per minute. When the first drone enters the engagement zone, the system opens fire. A stream of high-velocity rounds tears through the air, creating a dense wall of metal designed to shred anything that attempts to pass through it. The effect is immediate. One drone disintegrates under the barrage, its fragments scattering across the water. Another attempts to climb slightly, but the tracking radar adjusts instantly, guiding the gun's aim upward. The drone erupts into debris before it can travel another 100 meters. Above the battlefield, a pair of American fighter aircraft patrol silently, monitoring the wider airspace for additional threats. Their sensors search for any signs that the drone attack might be accompanied by manned aircraft or larger missile launches. For the moment, however, the confrontation remains concentrated around the swarm itself. Within several intense minutes, the sky above the tanker's route becomes filled with drifting smoke, fragments of destroyed drones, and fading rocket trails. What had begun as a coordinated swarm attack is gradually breaking apart under layers of interception. Some drones are destroyed far from the ships, others only seconds before reaching their intended targets. The final phase of the engagement becomes a race between the last surviving drones and the defensive systems determined to stop them. By the time the last intercept occurs, the outcome of the confrontation has already become clear. The swarm that once moved across the Gulf as a unified threat has been reduced to scattered debris falling into the water, leaving the tanker and its escorts still moving forward through one of the most dangerous maritime corridors on Earth. When the final drone disappears from radar screens, the tension that had filled every command center in the region slowly begins to settle. The tanker continues its course through the Gulf, its engines pushing steadily forward as if nothing extraordinary had just unfolded in the air around it. From the deck, the crew can now see small pieces of debris drifting across the water several kilometers away, fragments of what only minutes earlier had been part of a coordinated aerial assault. The ship itself remains untouched, its cargo intact, but the consequences of the attempted strike are already spreading far beyond the immediate battlefield. Inside the Combat Information Center of the nearby destroyer, officers review the engagement data in real time. Every radar return, rocket launch, and interception has been recorded and instantly transmitted through secure military networks. Analysts begin reconstructing the sequence of events, examining how the swarm behaved during different phases of the attack. Even small details matter. Flight patterns, signal emissions, and the timing between drone launches may reveal valuable information about the technology and tactics behind the operation. Military intelligence teams quickly focus on the electronic signals captured during the incident. As mentioned earlier, some of the drones transmitted short bursts of communication while in flight. Now those transmissions are being dissected by electronic warfare specialists. If the signals contain telemetry data or control instructions, they could reveal how the swarm was coordinated and possibly expose vulnerabilities in the system. In modern conflicts, information gathered during a failed attack can sometimes prove more valuable than the attack itself. Meanwhile, reconnaissance aircraft continue circling the region, scanning the Iranian coastline and surrounding waters for any additional activity. Satellite systems are also redirected toward the launch area identified earlier. Within hours, high-resolution imagery begins revealing increased movement at several coastal facilities, suggesting that the launch site was likely part of a larger operational network rather than an isolated installation. Intelligence officials quietly note the coordinates, feeding the information into databases used to track future threats. For the moment, however, the focus remains on maintaining stability in one of the world's most critical shipping lanes. Coalition naval forces escort the tanker until it exits the most sensitive portion of the Gulf, ensuring that no secondary attacks occur during the transit. International shipping companies quickly receive updates about the incident through maritime security channels, and within minutes, the event becomes a topic of discussion among energy traders monitoring global markets.